Hello viewers, good day to you all. You're welcome to today's class. I remain your pro guide Aisha Bande. The video is sponsored by Proch Connect. Proch Connect is an application for undergraduate, college of education, university or polytechnic students. Kindly go to your Play Store, search for Proch Connect for you to get started to get exciting and educative videos in all courses. So today we have a topic to discuss in chemistry which is known as electronic configuration. I'm going to explain some terminologies we need to know under this particular topic, and also we move on to looking at the calculation aspect of the topic. So basically, electronic configuration is written in accordance to the number of electrons found in every energy level available in the atomic structure of an element, starting from the energy level numbered 1. Also, under electronic configuration, there's what we call the atomic orbital. The atomic orbital is a region where there is a high probability of finding electron, which results to having a specific shape for each type of orbital. So now this takes us to the types of orbitals we have under the atomic orbital. We have basically four orbitals, s, p, d, and f. So we need to know that electrons are arranged in suborbitals using three principles. The first principle is what we call the Hofbau's principle. The second principle is called the Pauli's exclusion principle. Then the third one is called the Hund's rule. And Hund's rule has another name. It's either you to call it Hund's rule or it is called the principle of maximum multiplicity. That's the principle of maximum multiplicity. So this is another name for the Hund's rule, okay? So let's look at the explanation of the four orbitals I explained earlier, I mentioned earlier, s orbital, p orbital, the d orbital, and also the f orbital. The first orbital, which is the s orbital, has a spherical shape, and in the nucleus of an atom of this s orbital, the probability of finding an electron is very high. Okay, now for the p orbital has two adjacent spherical shapes in the nucleus of the atom, and the probability of finding an electron in the p orbital is 0. And also there's what we call the node point in the p orbital. The node point is the nucleus of an atom. So the nucleus of an atom of a p orbital is known as the node point. The node point has three degenerates, which are px, py, and pz. So moving on to the d orbital. So the five degenerate orbitals under the d orbital is dx, dy, dz, dxy, dxz, or dyz. So these are the five degenerate orbitals. So we have 1, 2, 3, 4, and then 5. Then moving on to the next orbital, which is known as the f orbital. The f orbital has 7 degenerate orbitals, with fx, fy, fz, fxy, fxz, fyz, fxyz. Okay, so these are the degenerate orbitals we have for f orbital. So another thing we need to know is that electrons are arranged in suborbitals by three principles. The first principle is what we call the Hofbauer principle. The second principle is the Pauli's exclusion principle, and the last one, Hund's rule. Another name for Hund's rule is the principle of maximum multiplicity. Let's write out the format of electronic configuration. Something very important we need to know is that electrons are paired up one orbital at a time. You start with the s orbital. You have to ensure that the s orbital is filled up before moving on to the next one, which is the p orbital. You fill out the p orbital before moving on to the next orbital, which is the d orbital. D orbital has to be filled up before moving on to the last one, which is the f orbital. That's why I said electrons are paired up to one orbital at a time before the next orbital of same energy is filled up. So let's write the format for the electronic configuration. So the format 1s, 2s, 3s, 4s, 5s, then 6s. So this is for the s orbital. So going to the next orbital, which is the p orbital, we start from 2p, 3p, 4p, 5p, then 6p. The next orbital is the d orbital, which start from 3, 3d, 4d, 5d, then 6d. Now moving on to the last orbital, which is the F. So we're going to start from 4f, 5f, 6f. Okay. So now let's bring out the arrows. So here we have 1s, here we have 2s, here 2p and 3s, here we have 3p and 4s, then we have 3d, 4p and 5s, then we have 4d, 5p, 6x, we have 4f, 5d, 6p, then we have 5f, 6d, then the last one, which is 6f. So let's bring out the configuration. So this is going to be 1s following the arrow. The next one that comes is 2s, then followed by 2p, then 3s, then we have 3p, we have 4s, then we have 3d, 4p, then 5s, then we have 4d, 5p, we have 6s, going to the next one, which is 4f, 5d, 6p, then we have 5f, 6d, then the last one, which is 6f. So this is the configuration. So basically, arrangement of electron in orbitals can be in form of a diagram or in a specified configuration. And under electronic configuration, there is what we call the abbreviated form. Okay? The abbreviated form has to do with using the electronic configuration of a noble gas preceding the desired elements and then filling the remaining valence electrons in the next principal equation level. So that's the abbreviation of. So that's basically the abbreviated form of writing electronic configuration. We shall explain this better, or we'll understand this better when we start solving some of the questions we have on the board.